Επόμενη ομιλήτρια είναι η κυρία Σοφή Τράχτε. Είναι πτυχιούχος αρχιτεκτονικής του Πανεπιστημίου Βίκτορ Όρτα των Βρυξελών και έχει πάρει μεταπτυχιακό τίτλο στην αρχιτεκτονική και τη βιώσιμη ανάπτυξη. Ολοκλήρωσε τις σπουδές της λαμβάνοντας το διδακτορικό της τίτλο στον τομέα της τέχνης των κτηρίων και της πολεοδομίας. Εργάστηκε στην κατασκευή νέων και στην ανακαίνιση μεγάλων έργων στις Βρυξέλλες, λαμβάνοντας μέρος σε διάφορους διεθνείς διαγωνισμούς. Στην επαγγελματική της πορεία ασχολήθηκε με την έρευνα και τη διδασκαλία, αναπτύσσοντας ερευνητικές εργασίες για περιφερειακά και ομοσπονδιακά ιδρύματα, την Ευρωπαϊκή Ένωση και διάφορους διεθνείς οργανισμούς ενέργειας. Miss Trachte.
Good morning, everyone. It's a great pleasure to be here, and I would like to thank you to invite me once again. My presentation is just before the lunch, so I hope that you are not too hungry. Today I talk you about building materials and grey energy consumption, but before that I would like to enlarge the focus on sustainable architecture. And for that, I just put on the slide the definition of sustainable development and also some data about the building sector in Europe. The building sector in Europe represents 25 billion of square meter built, and 75% of this stock are dwellings, individual or collective, and 40% of the stock were built before 1960. So our European stock are very old and need renovation or refurbishment. And building sector have also great environmental impact, and especially for energy consumption, but also for all natural resource depletion and also for waste production. So the question is how to design energy efficient buildings in a sustainable way. This is the big question today. And for that, I think an objective is to build building or renew building that interact a lot with the context. And when I speak about context, it's not just the built context, but also social context, economic context, and also with the climate. And in this, the first and the most important priority in this definition is how to improve comfort, well-being, and quality of life while limiting or reducing environmental impact. And these priorities could be worked in two scale of time, from the design to the demolition, from the extraction of raw material to the end of life, and recycling, and on the scale of space, from just a small room in the house or in the office building to the global scale of the planet, through different scale like the public space, the city blocks, and the city. In this definition of sustainable architecture, and with this great priority about comfort and well-being, I think building materials and the choice of building materials is a very important step. Why? Because building materials could help designer to go from an idea on paper, on laptop, to the real building in the real life. Also because selecting and assembling materials to create a building, it's a real complex process based on diversity of constraint and knowledge. Designer chose materials with subjective aspect like visual aspect, tactile aspect, acoustics, but also with some traditional or, like Florenzo says, mythology, We also choose material for technical aspects, insulation, mechanical, structural, chemical, and a lot of time we need to respond to some requirement, functional requirement, the use, the program of the building, the flexibility of the building, the maintenance. We have also some requirement for the urban administration or geographical. The economy is very important in the building sector. And since 1987, with the definition of sustainable development, we had two requirements, the health aspect and the environmental aspect. So why speaking about building materials and energy efficiency? Because when we improve the energy performance of a building, we use more and more building material, especially insulation. And so the environmental impact of building material and especially the gray energy consumption becomes proportionally very important in this context. So I would like to explain a little bit the graph on the slide. This is the hypothesis. It's just a small study for a single family house with different case of with different typology, massive typology and wood frame typology, and we try to change different material in the composition of the wall. So there is 4 different energy performance, and you could say directly that when we improve the energy performance of the building, we decrease the energy demand. But we compare in the red color, this is the gray energy needed by the building materials to build the building or to build the house, and in the gray it's the operational energy, the energy needed for the heating. So we could see that for a low energy standard, gray energy is almost the same than the operational energy, but for more performant or more efficient standard, the gray energy becomes very important. So when, as designer, architect or engineer, when we work on energy efficiency, it's also important to think about gray energy in building materials and try to decrease this energy consumption. When we speak about building materials and gray energy consumption, it's important to focus on the life cycle of building materials or life cycles of building. Life cycle could be defined as a set of all the transformation undergone by the material from the extraction of raw material to the end of life and waste treatment. And in general, we present the life cycle as a circle, but we could also present this in a line with the different steps: extraction, production, building site, and the use of the building, and then the end of life of the refurbishment step. Why present life cycle as a cycle? But because the objective is to repeat the cycle several times, more than once. And to explain that, I just present a small cases for concrete waste. In most of European countries, concrete waste is only crushed and then used for road construction and foundation, but we don't use the real potential of the materials. But in Switzerland, they use the real potential of concrete granulate and recycled granulate. They use this type of recycled granulate to produce new concrete. And this is a good solution for building waste. In the life cycle, each transformation of materials consume energy, especially fossil energy, and so each steps could pollute the environment, the air, the water, and so on. So we could now define gray energy. Gray energy is the energy required by the transformation undergone by a product throughout its life cycle. So when we speak about gray energy, we consider all the life cycle of the building materials. And gray energy is always calculated in primary energy and into 4 types of energy. On one hand, we have renewable energy and non-renewable energy, and then we make a difference between the energy that is in the material, like wood. Wood have a high potential of energy in his material, and we focus also on energy needed by the process. So I try to explain it in a small figure on the slide. But in a lot of publication, we talk also about embodied energy, and it's not the same as gray energy. Embodied energy focus just only on a small part of the life cycle. Embodied energy is just the energy required by the production process. So it takes into account of the extraction, transportation from the extraction site to the production site, and the production process. So how to find some information about gray energy and building materials? One good database is the Swiss database called Ecobilan KBOB. In Belgium, in the French part of Belgium, we also have a small database with different impacts and with some information about gray energy. And why focus on life cycle of building materials when we speak about gray energy? Because gray energy is one environmental impact, but it's not the only one. There is a lot of different environmental impact when we speak about building materials. So gray energy is in this category, but there is also other category. Building material consume a lot of natural resource, raw material, water, and so on. The process, the production process, extraction process, building process could also have an environmental impact, like pollution on atmospheric air, waters, and soil. Some extraction process could also have some impact on landscape and loss of biodiversity. Building materials use a lot of additive, and so they could also have some health impact for workers and for occupants. And we produce a lot of waste, and all these building waste have a high potential of recycling. Another point very important when we speak about life cycle and building materials is the transportation. Why? Because the transportation is a step that links the other step. And depending the distance and the mode of transport, this step could have a higher impact on environment and also on energy consumption. It's important to speak about building materials and transport because between 1990 and 2005, the sector of transportation has increased their energy consumption, but also the global warming potential. And as you see on the picture on the slide, we could also calculate the different impact of transport for each steps in the life cycle. And in general, the step between the extraction site and the production site is the most important step in terms of transportation. We could see that when we focus on the different mode of transportation, we could see that the impact, the environmental impact of those could be very different. And the real question about transport is, does local material really limit the impact of transport? Because in a lot of publications, a lot of people says to you, it's important that you use local building materials. It could really decrease the impact of transport. So the idea with the small study is to confirm this hypothesis. And we make a lot of different scenarios with different distance to cover, with different mode of transportation or mixed different mode of transportation. And you have some example on the slide. And this is the conclusion of the study. Yes, it's clear that the distance has an influence of the energy consumption of transportation, but the mode of transportation influences more the environmental impact, especially on small distances. There. And another small study about wood and different origin of wood. Siberian wood, Brazilian wood, and German wood, but with two different modes of transport, train and road. And we could see that there is a big difference between Siberian, who covered 10,000 kilometers by road, and Brazilian, who covered the same distance with boat. But what is very interesting is the small difference between the Brazilian and the German. So how to evaluate the environmental impact throughout the life cycle? By a life cycle analysis. The first life cycle analysis was done by a Coca-Cola company in the 70s, and we have to wait to 2006 to have a standard that regulates this type of analysis. I don't want to go deeper in life cycle analysis because there is a complex study. I just put some information. The different environmental impacts that be mandatory covered are the natural resource depletion, global warming, acidification, eutrophication, stratospheric ozone depletion, and photochemical ozone creation. What is important to know about life cycle analysis that the limit of the study could be different. We could have some life cycle analysis that we called cradle to gate. So we just focus on the extraction, transport between extraction to production and production. So we just have a small part of the life cycle, or we could also have some analysis called cradle to cradle and focus on the whole life cycle. Another thing very important that life cycle do not cover all the environmental issue. Only what is quantitative and extensive is taken into account. So today there is some environmental impact or environmental issue that is not covered and not studied by this type of analysis. Life cycle analysis is not a real tool for designer, for architect or engineer. I try now to present some tools that you could use in your practice, professional practice. First of all, the environmental product declaration. It's very similar as a life cycle analysis. It's not really a tool for designer, but as designer, you will be confronted by manufacturer, and a lot of manufacturer will be present to use some type of EPD. This is an example. There is different database of APD, French, German, Swiss, and so on. I just want to present the French one. You could see that they consider the gray energy consumption in this type of tools. Other tools are more useful for designer. I present them as a checklist. I just present briefly the different tools, the green guide, English tools, the Swiss tools, Dutch tools, and the last one, the Bow book. It's an Austrian tool. It's very interesting if you also focus on energy efficient building and passive buildings. We could also use software to realize some life cycle analysis for building materials, for walls, or all the building with systems. And for me, the best one is the EcoSoft. It's also an Austrian software, and the two Swiss software is also very interesting, especially for the design phase of the building. French tools also. And to conclude my presentation, I would like to present to you some comparison between walls and between different materials. First of all, a comparison between blocks, concrete blocks, terracotta, and cellular concrete. Cellular concrete is more and more used in Belgium and other European countries. How to compare them? We compare those 3 blocks with the same performance, but there is different density, and we could see that the density of building material has an influence. So this is the performance for the terracotta and for the cellular concrete. Thickness, thermal transmission, thermal inertia, and also acoustic performances. And so we made some study about over 50 years, and we consider the production process, the replacement if it's needed, and the elimination. So we have the result, and the result is just given only for the blocks, not for all the wall, because the other materials are the same in the 3 cases. And you have some different environmental impact. I just put a focus on the gray energy. Gray energy is important, but there is also other environmental impacts, and for some of them we made also qualitative comparison. This is for resource depletion. The red one is a good one, and the red one is a bad result, and the green picture is a very good result. And we make the same study for the recycling potential, and it's clear that for the European country, we recycling a lot of inert material, inert waste, like concrete, like terracotta. We crushed to make granulates, and we used a lot of those granulates. So the result is very interesting for the recycling potential. Another comparison, just for insulation, we compare 16 different insulation material, but with the with different thickness to have the same performance. And this is also the result for the result over 50 years. We consider production, replacement if it's needed, and elimination. And you could see that there is a lot of difference between insulation materials, but also that this is not really easy to find the best one because there is a lot of different criteria.
Ms. Trachte, you have 5 more minutes.
Okay. We could also compare different wall and different typology of wall. Traditional typology in Belgium sector, and another typology in wood frame. We compare those 2 walls with the same performance. It's very important to compare with the same performance. And it's important there in the wall there is not so much different building materials, so it's important to think about that for the elimination and for the waste treatment. Here there is a lot of different materials. And this is the environmental impact. So we could say that for the gray energy, the first wall, it's very interesting. But for the global warming potential, the second one in wood is very interesting too. So the comparison, it's difficult. It's difficult to make a a choice, but I think designers have some priorities when he propose some new project. Gray energy in the wood frame is very important. Why? Because for this type of structure and typology, we use a lot of wood panel, and those wood panel has a high demand of energy during the production process. But the idea with wood is that this wood is a storage of CO2, so the global warming potential is very, very small. The same study for resource depletion, qualitative study, and for the recycling potential too. So my conclusion for today about building materials and gray energy consumption, I think it's also the same for energy, operational energy in use. Thank you. First of all, we have to rationalize and optimize the use of building material, like for energy. And I propose some guidelines align the building process and the lifetime of building. It's very important. Choose building process that allow adaptability and evolvability. How to do that building could respond to the use of today and could respond to the use of the future. Encourage techniques which allow prefabrication or pre-assembly. It's important to reduce waste on building sites, and when we don't have waste on building site, we don't have to manage it. Optimize the dimensioning of the building elements, and a big question, the question of finishing. How far is painting necessary in any case? Is the concrete could be present in a building? This kind of question important. And then we could expand the set of environmental criteria, take the gray energy criteria, but also other environmental impacts. And we could have this type of analysis for just material, but also for all the building or all the wall and component in the building. So expand the set, saving resource, reduce environmental risk, and reduce health risk on worker and occupants. So, for my opinion, two criteria are very important today. It's clear that energy is a big issue, but for me, building is built for user, and the health impact is very important in building. And the second one, because we use a lot of resource, and we just have just one planet, we have to think about waste in building and to consider this waste not as a waste, but as a new raw materials with a high potential for the building sector and valorization. Thank you.
Υπάρχουν ερωτήσεις?
Thank you. It's a small technical question. we were amazed by the similarity of gray energy in massive and wood frame construction. Did you take into account the recovery of embodied energy in wood frame construction, because we can burn wood and recover a lot?
Yeah, no. In this study, we just focus on production and replacement. We don't focus on the construction process and recycling process. And normally in life cycle analysis, when materials has a great potential of recycling, this potential is used for the new product. So if a building material use recycled materials, the added value of the recycling is used for a new building materials. Yes, but it's clear that wood is a good materials for gray. They don't use a lot of gray energy, especially in your country, in Austrian and German, because you have a big wooden stock. It's not the case for Belgium, for example. We import a lot of wood, so also the transportation step is more higher than for Switzerland. But in wood frame structure, we use a lot of wood panel, fiber wood panel, and those panel need a lot of energy during the production. So this is.
Thank you very much for your presentation. I have like 2 or 3 questions, but I think they're all related, so I'm just going to state them and maybe you can ask them all together. National data is a key issue to be able to handle this. Are you aware, for example, how many different national databases or how many countries are up to a level where they can say we can handle this kind of an analysis? Having said that, are you, have you done any studies, or you're aware of someone pulling all these different tools that you put up there and say, okay, let's try to put them, to use them for solving a single problem and see how many, and if there are any significant differences, there will be, but how significant, especially if and how that would affect your decision-making process. That if I use a tool, I would conclude or reach this decision or whatever. Yeah, and the third one is you keep mentioning about building materials per se. Now the other parts of the complete building is all the electromechanical installations there. And one example is for very popular in refurbishment action, for example, here in Greece, is we take all the old oil-fired boiler and we replace it with a natural gas boiler. So when you're referring to all this work being done for the building envelope materials, is there similar progress, or there's still a need to address the electromechanical installation?
For the tools comparisons, it's we do this study to try to compare the different tools and try to identify the difference between the tools. But it's really difficult because when country makes some life cycle analysis, they don't use the same hypothesis than another country, and not the same method also, because there is different methods to do that. So it's difficult to compare the results of the different tools. now the European country work on harmonization for life cycle analysis and environmental product declaration. So we have new an harmonization for the method to be used. So I think all the tools will be more easy to compare in a few years or few months. This is the first. I think with building materials and life cycle analysis, we are in the first steps. And we have a lot of way to have the real result about building materials and environmental or health impact. The way is very long to have some real result. So I think we could also use different tools to have an overview about building materials and environmental impact. I think the overview is most important than the real results. I don't know if you understand me. Okay. And yes, I focus my study about building materials because I'm architect, so I'm always doing with building materials, but it's clear that all technical systems in a building consume also a lot of gray energy, and it could be also interesting to identify this impact and also to quantify this impact. I have a colleague in another university in Belgium who make a PhD on a global vision about gray energy in buildings. He analyzed building material from the envelope and component into the building. He analyzed also the different systems used in building, heating, cooling, ventilation system. And he'll try also to make some scenario for the occupants' transportation. And if you want, I could give you this name and you could be in contact with him.
Another question.
I would like to ask you, mentioned, I think just before that slide, that you compared 16 different insulation materials with the same U value, I suppose. What was the result of if you have it there?
This is the result. So we study those insulation material over 50 years, taking into account of the replacement if it's needed and the elimination. The first one, it's synthetic or plastic insulation like polystyrene, or then you have the mineral insulation, and then more insulation coming from plants and so on. The light red insulation, it's cellulose flux, and you see that the result for this is really interesting for all the criteria. There is, I think this is wood fiber, because the density of insulation material has an influence on the environmental impact, because environmental impact, grey energy, global warming potential, and so on, is calculated by kilo. So if if the insulation material has a high density, so it's the environmental impact is more higher than another one. But if you are interested in it, I could send you the study.